Welcome everyone to the Migrating Java UI Client Applications to OpenJDK 11 session. This one's actually being live streamed, so I could put on the live stream of me if you want, but I'm told it's actually delayed by several seconds. I'm going to go. Okay, still getting some echo. We'll see how it goes. So my name is Phil Race. This is Sergey Bylokhov, a colleague in the Java platform group at Oracle. We both worked on in the UI client stack for quite some number of years. I don't really want to admit how many. Okay, let's just get started. Safe Harbor, read that again. You probably read it 20 times already. Okay. Okay, so what's the focus of this session? Well, 8, a lot of people are still using it. We've then gone through 9 and all the massive changes that happened then, and more things have changed in 11. And things have changed for different reasons. Most applications out there are probably still based on 8U. People haven't got around to picking up 9. I refer to desktop applications here because this is very much, client applications is very much the focus here, but I'm sure that it's even more true of server applications. And we know that 9 people, if they're able to follow the new release model, right, which it's hard enough for some people internally, right, they will know that 9 is already, even though it released last year and 10 were released early this year, they're already out of support. And from the community as well as Oracle are basically focusing on 11 as a long-term support release. And 8 is, you aren't going to be required to stop using the 8s, the downloads of 8 that you've got, but there won't be any more security public updates, so it will stop being free basically for if you want to get keep on a supported platform. So generally what we're trying to do here is help you understand what has changed, what the impacts might be, what mitigations you can do when you're migrating from potentially as far back as JDK 8 up to JDK 11. Okay. So these are some of the kind of broad topic areas: OpenJDK, Oracle JDK, specific application migration issues, the removal of FX and the removal of deployment technologies are also things that could potentially impact client applications. Well, not just potentially. Okay, so OpenJDK, why am I going to talk about that? Well, it should become clearer as that goes on, but the OpenJDK project was launched by Sun way back. This obviously meant that all the OpenJDK project source had to be under an open source license, and this was the GPL v2 wherever that was possible. We, meaning Sun, had lots of component code in the JDK that it was not possible to release under such a license, and those stayed as closed sources. So that meant that whenever you went and got the Sun JDK and then the Oracle JDK and you got your binary download from java.com, you didn't get OpenJDK. You got Sun JDK and then Oracle JDK. Sun and then Oracle put out reference implementation binaries of OpenJDK, at the moment that it shipped, and said, oh, look, this is to prove that it is conformant to the specification, and then left it there. And that was it. There was no updates, nothing. You wouldn't even find it unless you knew where to go to look for. You weren't supposed to use it. No security updates. Oh my God, there's a massive security update hole in it. Well, we're not updating it. That's not supposed to be used. So, okay, sure, there are companies like Red Hat and the Linux distros that will ship OpenJDK binaries as part of their distribution. But for the most part, applications are being using Oracle JDK. And remember that plugin WebStart were not open source, not part of OpenJDK, and nor was JavaFX. Even though JavaFX was open sourced along the way, it never became part of any kind of OpenJDK builds. Well, it was it's like a separate project. However, Oracle JDK co-bundled it. So JDK 7 was the first time that we actually had, simultaneous releases of Oracle JDK, OpenJDK. This is repeating a lot of what I said. Source project, no binaries, but people continued to use the Sun JDK because, well, it was, it wasn't open source, but it was free, completely free for commercial use. You got free commercial updates for many years. Although the end of public updates for JDK 8 is coming, to date, it's still pretty much you go out, you can download a free JDK 8 binary, which you can use in whatever commercial enterprise you need or you have. So not many applications then tested against OpenJDK. Nobody deployed on it. And honestly, even Oracle really focused only on testing Oracle JDK. Sure, we absolutely make sure that OpenJDK passes the conformance suites, JCK, absolutely it does. But our SQE, the builds that our SQE teams were getting were the Oracle JDK. They didn't have the resources to do the same extent of testing on OpenJDK. But this is all now got to change. Oracle JDK is converging on OpenJDK. And all those closed source components have been dropped, and the client area is a huge consumer or a huge source of those closed components. And this is all happening in OpenJDK 11. So JDK 11 and Oracle JDK and OpenJDK 11 are very, very similar, and essentially they're what OpenJDK was in 8, 9, 10. But this is also against the backdrop of all of the other things that's changed. So it's not just like, oh, this is OpenJDK 8. Remember that a lot of other things have changed in this time frame. So focusing still at this section, what's changed in OpenJDK? It's quite a long list. Font rasterization, people care about this a lot. That moved to free type from T2K. I'm going to go through each of these in detail. Well, most of these in some detail. We removed some Lucida fonts. We changed anti-alias rendering. We removed, literally removed some JPEG library API that had been there because it was non-standard. That's one of the consequences, actually, partly of not it being closed source and partly because and it was never part of OpenJDK, but also because the module system had an impact on that. Image processing went from a proprietary library to an open source library. We also then, and we did that earlier, and I'll talk, but we now had to remove the ICC profiles, which were proprietary. Then there were a bunch of other updates as well. Okay. As well as that, we had changes due to features, the Java module system, Jigsaw, which I just touched on. There's no 32-bit JDK anymore. Most client applications, I would say, probably, I think, still try to use the 32-bit JDK, and that's what was generally being used plug-in within the browser. It had. It was for client applications, you didn't need to be processing necessarily terabytes of data or something, so it was perfectly fine to use this, and it had perfectly okay performance at runtime and started up more quickly and less footprint. We also have this change which came in JDK 9 to have proper HiDPI support for Windows and Linux as well, although honestly, yes, we know people use client applications on Linux for quite serious reasons, but the majority of client applications are basically dealing with Windows. So what kinds of impacts are we talking about here? Source code incompatibilities. Your source code no longer compiles. You're going to have to make changes. Binary incompatibilities. We've taken stuff out. So your code, even without recompiling it, may no longer run. This is, something that's almost unheard of, right, in the Java ecosystem, right? We've been so concerned about compatibilities. The module system will have impacts and ties into some of these other things. There may be behavioral changes, performance changes. I say changes, some for the better, some for the worse, and removals of components and functionality and new features. This is HiDPI is kind of the prime example of this, which might require you to update your code for the best results, or to avoid the worst results even. Okay, so text rendering, measurement, and performance. We know that people care about text quality and things like that. And we know that people care about, text measurement. We know that people care deeply exactly what something looks like. But when we had to remove the closed component that was used for rendering the vast majority of the text that you would see in your UI, and we switch over to free type, there are going to be some differences. It seems to vary. Some things seem to vary depending which build of free type you have. No longer are we necessarily getting this is the rasterizer, the font rasterizer that Swing uses, that's bundled in the JDK, and I know that if I test this thing out, it's going to be the same from release to release and whatever to whatever. But while we bundle it on Windows, we bundle it on Mac, we're picking up whatever Linux or Solaris actually includes. And there are definitely some behavioral differences that we're seeing. So, you may just see that your text doesn't lay out as the same. You may also see that you think it looks worse. We know of at least one bug that needs to get fixed soon in this area. And text quality is basically something which is very, very close to some people's hearts. The number of passionate arguments on mailing lists about this over the years has when things like JavaFX, which basically started out using 2K, but then migrated to using the platform API, people would still complain bitterly that this wasn't correct. Just calling the same API as the platform. Okay, not good enough apparently. Okay. And T2K, which is the closed source rasterizer, wasn't necessarily perfect. In fact, it wasn't. There were, but sometimes you've adjusted to what's there, and if we change anything, it might have impacts upon you. And it isn't necessarily that free type is doing something wrong, because there's a lot of leeway in terms of how different platforms or different rasterizers might work, and there's so many ways that you can configure free type when it's built, when it's run, etc. Okay, layout of complex text. Arabic. Means languages like Arabic. We used to use a library called ICU, which was from an IBM project. It was basically dropped by ICU, no longer supported. Ancient didn't really have any support anymore. We had to migrate to using a new library called HalfBuzz, which is very well maintained, very actively developed, new features going in all the time, releases, being adopted all over the place. So we're on the right track there. It's much more secure and generally should be more performant, apart from some own goals on our side. So we have seen, because of those own goals, I think, we have seen some people saying, well, this doesn't actually seem to perform as well as it did before. I'm seeing performance regressions, which we don't really expect, and we're realizing are really things that we need to work on and work out the kinks of. But this is because whenever you go into code like this, it's incredibly performance sensitive, and it can slow down the rendering of your application. You may see with like laying out some text, if you've got something that looks like a word processor kind of thing and you're very sensitive to layout, it might run slowly. People have said that just relaying out their application is noticeably slower because of some of these problems. So we need to work on those, we know. Since JDK 1.2, we shipped a bunch of fonts from Bigelow and Holmes called the Lucida fonts. They were applications became to depend upon these because you go back far enough certainly, and platforms actually had relatively few fonts, and they didn't necessarily have great coverage in terms of languages and other like symbols and other things like this. And people actually became hardwired into their application dependent upon these fonts as much as they did the logical fonts. These are licensed, right? These are fonts. We cannot put these into OpenJDK. So when Oracle JDK becomes OpenJDK, they're gone, and these are gone in 11, just like that, very abruptly. There's no deprecation warnings again or anything like that. This is just a closed source component. It's not part of the specification, so it's gone. And this can have, unfortunate effects. Because you were asking for some font, one of the Lucida fonts, which is a fixed width font, you now get, everything will just fall back to dialog basically, which is going to be typically something like Arial, which is a variable width font. Your application could lay out quite wrongly, quite differently than you expected. And you might get a serif font. When you if you ask for Lucida Bright, you would get a serif font. Now again, you'll get a sans font. If you're not a font wonk, that may not mean a lot to you, but you'll know it'll look wrong. You'll know when you see it. And it was used as a fallback for logical fonts. In fact, I've seen bug reports recently because even on Windows, if you don't set a font, right, you are typically using what's called dialog, a logical font. This is whether you're using HiDPI, Swing, anything, right? You will get this logical font, which, on Windows for like the last 15 years, a lot of these languages actually were supported by the Lucida Sans font, which you were automatically getting as a fallback. It's gone. So we're now seeing applications saying, sorry, I'm seeing boxes. Why is that? So I think we'll try to do something about that, but in an update release probably. But these are the kinds of, it's another example of the kind of thing that you'll see. There's an ancient API which we put in 1.2 called cont'd codec, which would read and write JPEG images. Lots of applications adopted it back in the day because it was the only thing there was that could write JPEGs. It was, again, really a closed source kind of collaboration license via Kodak. 1.4 came out 2002 or something, introduced a standard replacement. So I've mentioned this in previous sessions, so really people should have migrated this to this one by now. But if you've got some legacy code, and I've seen legacy code like that in Oracle products, it's just going to not run because this is gone. This was never part of OpenJDK. People who were running on OpenJDK found this out a number of years ago. The people who weren't and haven't been won't. Well, we'll find out when they try 11. We also had some proprietary extensions for that even applied in ImageIO in the native library for reading and writing JPEGs. And so we would be able to support writing a JPEG, an image with an alpha component. That'll no longer work. That was closed source support. The specification was written in a way that made it optional. Gone. This actually happened in JDK 8, but we replaced the Kodak color management system with an open source one. And in JDK 10, we actually stripped out KCMS. There was still a way so there's still a way to get it in 8 and 9. And it has come to light that PDFbox, which is an Apache project, I think, and seems to be quite widely used, has always asked for KCMS since once they found out that Little CMS was in there, even though Little CMS is modern. Little CMS supports modern color profiles. KCMS was not that great and certainly cannot support ICC 4B4 profiles. So why were they trying to go back to using KCMS when Little CMS was there? This is an under the covers thing, right? You don't know that it's happening. It's just something that the implementation does for you. Well, it turns out that the reason was performance. I mean, the Kodak library always would look and try to look to see how many CPUs were available on the system and partition the work and would spawn up to 4 threads. So it could be up to 4 times faster than the little CMS library. And you know, people run these things in workloads where they notice when something becomes 4 times slower. If you have that kind of workload, then you would have to do something like little CMS, like KCMS does, but at your own in your own code. So buffered image, which is not called out here on this slide, but the image type here is a buffered image. We can get its width, we can get its height, we can do, there's some very simplifying assumptions in this code. And we can basically split the image into sub-images, or bands the same width as the main image, and then create threads for each band and basically have the color processing code, so the color convert op, which is the last line here, go off and do the color conversion on each of the sub-images in parallel in different threads. There's a lot to try to get everything on one slide, I've elided a lot of details here. So there's the magic process image on new thread call there, which will basically go off and call this run method. But by doing this, you can get back that performance. I mean, it's a technique that you could have used already in your code and maybe then got 16 times performance. But I've run this on small images and it doesn't make much difference. But if you've got any image that's, getting, sort of like 500 by 500 or above, it makes a noticeable difference. And certainly when you get an image that's the size of what you'll get out of a digital camera these days, like a couple of K or it makes a huge difference. Color space conversion doesn't just use a library. This is a very wonky subject, so if you don't care, sorry. But there are these profile files that we have shipped within the JDK for since Java 2D went in 1.2, and these define essentially the characteristics of a color space for conversion between the different color spaces. And we had licensed these, I'm pretty sure, along with the KCMS library from Kodak, although I'm not sure exactly where they all came from. But we had essentially commercially licensed versions of these profiles. And these are what that little CMS library will be reading to interpret a color profile, to convert between color spaces. And it's the data you're operating. It's almost like, this is similar to saying, okay, I've swapped out the font. I've now got a different font file. So the results can be different. How much they matter and how much you notice them, it depends on whether this is an area that affects your application. If you're not sensitive, you'll have no idea. But if you are, we have automated tests where you go, oh my God, everything is different. No pixel is the same anymore. But they're still, that means they're slightly different, and the naked eye can't tell a thing, but the tests can say, oh, this is wrong. This is a bit of a shout out, really. Another closed source component that we had to remove was called Ductus. It was used for anti-alias graphics rendering. OpenJDK had a version called Pisces, which was dog slow. I mean, so slow that people really couldn't use OpenJDK for certain workloads. And when I use the word workload, I mean, I don't just mean that you're running this in a client application. People will be using this on server applications as well for mapping and things like that. So Laurent Bourge, I forgot to put the graph on there, sorry, Laurent, worked to take Pisces and make it much more performant. So it went from being terribly slow to even single-threaded being very comparable to Ductus. And Ductus had a global lock, so for a lot of things on the server side as well, or even on the server and on the client, you would be bottlenecked because it was single-threaded. Pisces actually is, sorry, well, Pisces as well, but it was too slow. But Marlin doesn't have any problems with running multiple threads concurrently, so actually can be many times faster. Laurent gave a great talk on this actually last year. And we have had a few bugs reported, but nothing terrible. Oh no, I've got a typo. Anyway, most of these are already resolved. Okay, so that's it, I think, for all of the consequences of the changes that we had due to moving from OpenJDK from Oracle JDK's closed sources to OpenJDK. Let's talk about some other things. So, unless you've been living under one of those rocks, you know that the module system came in JDK 9. It's been talked about for many years at these kinds of at Java 1 and similar conferences. And one big goal is encapsulating internal APIs. It's not forcing that by default in 9, 10, 11. It'll happen at some point. But it also meant that there's some consequences. We had to say, what is an internal API? What is a standard SE API? So we had to remove the peer package. Java Auth Peer had been there since 1.0. It was deprecated essentially in 1.1, but applications were already using it. Lots of products used it because, this is the way I find out if something's actually being put on the screen. If it doesn't have a peer, then so they would reference these APIs. There were public replacements for most of the things that we saw people doing have existed since, in some cases, 1.1 or 1.2. But applications were still using these. So if your code has this legacy stuff, it's another example of where it will just not run on 9 or later. So this isn't just an 11 thing. This one came in 9. If you're directly instantiating swing system look and feel classes, which you've seen people do, this is now essentially an eternal encapsulated class. You can't get at it. I mentioned the JPEG classes already, JPEG classes. And just lots of little internal APIs being gone, moved somewhere else. So where we know that something like this was, people were using internal APIs, we have tried already in 9 and 10, 11 to provide public supported replacements. So if you are encountering problems like this where your code just doesn't run because it can't find some class, some package, then go look around in the API. There's probably a replacement. And I'll give you a resource at the end to a presentation I gave on some of these topics, which goes into some of these topics in great detail that I gave last year. And you can go find that talk. HiDPI support for Windows. So the Java window size itself and all content are now scaled up to match the Windows DPI setting. So Windows started having this behavior from Vista onwards, where if you were scaling if you set a large font or whatever, it would scale up your whole application, not just the window. JDK had always opted to opt out of that behavior, and because we didn't want to be scaled up, we'd look fuzzy. So we said, no, please don't scale us up. It'll look horrible, And this is okay, so as far as it goes, and was okay for a long number of years. Then, of course, we started to see very high-resolution displays came out. Apple were the first company that really had this in volume with their Retina displays. And so quite some while ago, we actually had to have high-resolution support for Retina on Mac. But it was actually quite simple on Apple. I mean, they didn't go out and, they basically have 2x scale. That's it, Steve Jobs said, we're going to do 2x, it's going to be integrated, it's going to be much, so we control the hardware, we control the OS, so okay, this is what it's going to look like. And it actually was so it's the easiest case to deal with. But this isn't what we have on Windows. There's basically a little slider. You can say how much you want it to scale, and people, There's all sorts of different devices out there. So when you get to something like a Surface Pro that's a very high resolution device, and JDK is opting out, you get a postage stamp for a Java window. And now it's got to the point where, I would have preferred fuzzy, because I actually can't read this. So JDK 9 said, okay, well, what we're actually going to do is we're going to try to do this properly. And we're going to, let the window size be the size that Windows would actually want it to be if it was auto-scaling. But we're going to have a back buffer, and we're going to basically scale, have everything scaled to the native resolution so that it will look crisp and sharp, just like it does on the Mac. But there are consequences for applications here, right? If you've got some little, all your little icons in your toolbar, and you've supplied those as part of your application, well, we don't magic up a new high-resolution icon for your application. That can't happen. If you'd done it using vector graphics or something, then you'd be great. You'd be fine. But if you were doing it using the typical way with icon images, then they are being scaled up, and they look a bit so-so. There are more pixels to push, so performance could go down, and sometimes a completely different code path is taken. We had a discussion on one of our mailing lists very recently. So somebody was just trying to draw, lines, and the performance degradation for drawing lines in 9 was, or 11, whichever they were looking at, was terrible. When they weren't doing anti-aliased or anything special, it was just horrible performance degradation. And it took a while for us to realize that what was actually going on is because these are no longer pixel-lined lines. It goes through a completely different code path of building essentially a shape and then rasterizing that shape. And the performance degradation was appalling. So now, having said that, right, they were actually looking at what was an incredibly fast piece of code that just drew bi-level, thin alias lines, and so it could do gazillions of them. So now it's slowed down to something that was actually comparable, in fact, still faster than what you got if you'd been drawing thin anti-alias lines in JDK 8. But it was the performance degradation for their case that actually made their application slow to resize, etc. So if you're copying unscaled content to the screen, you draw to some off-screen buffered image, that you say is, it's going to be 300 pixels by 300 pixels, and then you do all your rendering. Maybe this is the main body of your application even. You then copy it to the screen. It's going to look fuzzy because we had to scale it up. So we've had to deal with this in our own demos. Be aware that you may need to look now to say what is the actual resolution of the screen. My talk last year, which I'll again refer you to, actually has some tips about how to do that. Anyway, if you think this is your problem, you can try -d sun Java 2D UI scale equals 1.0. Okay. No JavaFX in JDK 11. It had been there for a while, but if you try to run this now, by just saying Java myFX application, you're going to get an error like this. No class. So you have to go get the unbundled JavaFX OpenJFX 11 from OpenJFX.io. It's delivered in different ways, but so I'm only really showing you one way. Download the SDK, unzip that, and then you will have to then put the FX on your module path, which is the JDK 9 module system equivalent of the class path, and add the FX modules to your path, and then run it. So it's now essentially just like any other third-party jar that you need to run your application. It's actually got to be part of what you deliver with your application. So the launcher still knows how to initialize FX applications, but that may change in the future. So you might need to do more later on. I doubt anybody missed this, but the deployment technologies are gone in 11. Plugins removed, web starts removed. We removed the Applet viewer tool, which is a little utility, and it's in many of its implementation classes. We haven't removed the public Applet API. It could happen. But it's, it's not clear. We might. So anyway, with this removal, you can't deploy over the web anymore. There's no more browser integration. For people who were using applets, well, this writing was on the wall anyway. Whether we'd done nothing or not, this was going away. Chrome was first, then Firefox, and now the current version of Safari no longer supports it, so it just doesn't work. Internet Explorer does, but you go run on Windows 10 and people aren't running IE unless they go out of their way to do it. So it's become very hard to deploy applets over the web now anyway. So what do? Well, okay, I know that there are other solutions out there that, open source solutions that are trying to help you with open source equivalents of WebStart and commercial things and other things that do clever stuff where things run on the server. I can't I can't go out and recommend that you adopt some commercial solution, but I can just talk about what are some of the things that you could try to do if none of those things would work for you. So you're going to have to go the route of basically installing this as an application, is the bottom line. You could convert your applet to a main program. If you've got some absolute dependency on having some way of still showing something that needs to be in a browser, there are a couple of APIs that we have that can help you. I'm not remotely going to claim that these things are panaceas or take you back to where you were or anything. But JarFX has a component called WebView, which is based on AppKit, which is what Safari uses and works just brilliantly, basically. And there's an API in the Java Auth desktop class which will open up a URI for you that, and I'll show an example of that. But anyway, so the path forward really has to be used, and this is not a talk on this at all, but we hope to have a tool called JPackager coming up. There's a JEP out there. It's even out for code review now, with the hope it'll go into JDK 12, but the formal process is that it doesn't go in until it's ready. So, but the intent is that it will be able to create bundles targeted for to 11. So you will be able to use JPackager in JDK 12 or 13, whatever it is, and actually create bundles that will run on JDK 11 LTS. And if you had a WebStart application, we also are writing a little tool that will consume the JNLP file and output all the magic and invoke Packager and JPackager, and will help you migrate to basically be your JNLP application to being a packaged application. Yeah, so you're now going to have to deploy your own runtime rather than relying on what was there on the system. Just a quick tip that since the JDK is bigger and bigger and bigger and bigger, and now we have all these JMod files in there, and for instance 9, it can be very big. Full JDK, then there's no separate JRE anymore. A JDK image can be, on Mac, is like 300 megs. You can actually, if you use JLink, reduce this. JLink is the standard tool since JDK 9 provided the module system, down to some more manageable level. And with the right magic options, this should come down to, can come down from what? That's reduction of like 85% or more even, which I think is worth doing. And I don't know this for a fact, but I'm hoping, and it should if it doesn't right now, but JPackager should be able to consume all of these JLink options and do that for you. So if you're building a native Windows installer or a Mac de-image for using JPackager, that it would be able to consume these options and do that as part of it, rather than having to do it as a separate step. Converting applets to main programs, no rocket science. So if you've got something that is an applet, how do you actually rewrite it is the question. Well, as long as we don't remove the applet API, which is a risk, you could basically subclass applet and provide that. Okay, I'm told I've got 5 minutes or something. You could rewrite your, you could provide your own implementation of the applet API, just basically subclass applet and I think I've got an example coming up. I'm going to go quickly here. WebView, I mentioned this. WebView is a JavaFX component. You can embed it in a Swing app. So here you can create this panel called JFX panel is part of FX. You create a JavaFX scene. This isn't a tutorial in JavaFX, no time for that. But then you create a web view, and you can tell the web view to load any URL you like. And then you basically just set the FX panel as like a regular Swing component as part of your application, and you've got access to the web now embedded in your application. Rather than your application being embedded in the browser, it's kind of the other way around, but people have done things like this. And this is what I was touching on. You can embed applet classes, sorry, extend applet classes and do some of the things that it was doing for you, like you can create, just get image, just call toolkit get image. You want an applet context. Why do you want that? Because you can then call, provide the show document API that the applet class, applet context classes has in 1.1, which opens up some other URL in the browser. Well, you can use the desktop action here, desktop browse that I was touching on before. So, so you could. This will basically open up your browser for you, just like show document did. So most of the disruptive changes are already there, and if you can absorb all of this, then I think the future is actually going to be a bit smoother sailing. It's not to say that there won't be some things that happen, but you're going to be in much better shape. More information. These are a couple of talks that we gave in previous years. I've put them up on CR OpenJDK Java Net, including this one. So you can go and look for it. Because I assure you I can never find anything in the Oracle conference catalog myself. Okay, so what do you got to do? Test, measure, report. You know, really recommend testing this stuff as soon as you can. If you see problems, tell us, right? What are you going to do? Well, you report those issues at JavaCom. You could join the OpenJDK community and help contribute fixes. And if you're a commercial organization, well, you know, you don't really have the ability to get involved in the community, you can always go get one of them Oracle support subscriptions. I'm sure Larry would love it. Okay. That's it. And I have 1 minute for questions. Yeah, sure. Yes, and if you've got time, you could run up to the microphone, because then people can hear it. Yeah, that microphone right there. If it's not on, just I'll repeat the question.
1, 2.
There's no mic. Oh, hey, never mind.
Hello.
Hey.
The Lucida font is gone from the OpenJDK. Is it still there in Oracle's JDK?
No, it was never in OpenJDK. It was in Oracle JDK, and it's gone from Oracle JDK.
From both. Okay, thank you.
Yeah.
Phil, one of the nice things on the Swing components is you essentially get, or used to get, printing for free off them. Is that still going to be there, or are all these changes going to break that?
Would they break printing?
As in, you could use JPS to print the components. My question is whether these changes are going to alter that, or whether we still get that functionality available as well as the UI in Swing.
You should still be able to print. I can't think of anything that would change that. Okay. We're at 45 minutes and a bit, so, okay, thank you.